What if I told you there are worlds out there that could potentially harbor life, just like Earth? That's right, we are about to embark on an incredible journey to explore 15 planets that scientists believe could be habitable. In the vast expanse of the universe, the search for life beyond our blue planet has captivated our imagination and driven countless hours of research. But why is this search so important? Discovering habitable planets not only expands our understanding of the cosmos, but also holds the key to answering one of humanity's greatest questions: are we alone? Stay with us until the end as we delve into the mysterious worlds that could one day become humanity's new home and uncover the latest discoveries that might redefine our place in the universe. The key criteria that make a planet habitable are liquid water, a suitable atmosphere, and the right temperature. Liquid water is fundamental because it is a universal solvent that supports countless chemical processes vital for life. Without it, biological activity as we know it would be impossible. Next, a planet's atmosphere plays a crucial role. It must not only provide essential gases like oxygen and carbon dioxide, but also protect the planet from harmful space radiation and help maintain a stable climate. The composition and density of the atmosphere can mean the difference between a thriving ecosystem and a barren landscape. Finally, temperature is a critical factor. A habitable planet must be within the Goldilocks zone, a region around a star where temperatures are not too hot and not too cold, allowing water to remain in liquid form. If a planet is too close to its star, water would evaporate; too far, and water would freeze. These three criteria, liquid water, atmosphere, and temperature, create the delicate balance needed to support life. As we journey through these 15 potentially habitable planets, keep these factors in mind as they are the foundation upon which any search for extraterrestrial life is built. The second planet on our list is Kepler 452b, often hailed as Earth 2.0. Discovered by NASA Kepler Space Telescope in 2015, this exoplanet has captured the imagination of scientists and space enthusiasts alike. Situated about 400 light-years away in the constellation Cygnus, Kepler 452b orbits in the habitable zone of its parent star, Kepler 452, which is remarkably similar to our own Sun. One of the key reasons Kepler 452b is considered potentially habitable is its size and composition. It is about 60% larger in diameter than Earth, placing it in the category of super-Earths. Scientists believe it has a rocky surface, which is crucial for supporting life as we know it. The planet's orbit around its star is another intriguing aspect. Kepler 452b completes a full orbit in 385 days, which is very close to Earth's 365-day orbit, suggesting that it experiences similar seasons and a stable climate. Furthermore, the star Kepler 452 is slightly older than our Sun, around 6 billion years old, giving any potential life forms ample time to evolve. This extended period increases the likelihood that the conditions on Kepler 452b have remained stable enough to support life. Studies suggest that the surface temperature on Kepler 452b is conducive to the presence of liquid water, another vital component for habitability. The distance of Kepler 452b from its star places it in the much-desired Goldilocks zone, where temperatures are just right for water to exist in liquid form. While we have yet to gather direct evidence of water or atmospheric composition, the tantalizing possibility places Kepler 452b high on the list of potentially habitable worlds. Imagine standing on this distant cousin of Earth, gazing at a familiar yet alien sky, pondering the mysteries of the universe. With every new discovery, we come one step closer to answering the profound question of whether we are alone in the cosmos. Next, we will explore yet another fascinating exoplanet that holds the promise of habitability, Proxima Centauri b, which is right in our cosmic backyard. The third planet on our list is Proxima Centauri b, our nearest neighbor in the hunt for habitable worlds. Orbiting the star Proxima Centauri, the closest star to our solar system, Proxima Centauri b is located a mere 24 light-years away from Earth. This proximity alone makes it an intriguing target for researchers aiming to find signs of extraterrestrial life. Discovered in 2016, Proxima Centauri b has been the subject of much excitement and numerous studies due to its potential to support life. One of the key factors that contribute to its habitability is its position within the habitable zone of its parent star. Proxima Centauri is a red dwarf star which emits less energy than our Sun, allowing Proxima Centauri b to be much closer to it while still maintaining temperatures that could support liquid water. In fact, the planet orbits its star at a distance of just 5 million kilometers, significantly closer than Mercury is to our Sun. This tight orbit results in a much shorter year, with Proxima Centauri b completing a full orbit in just 11 Earth days. Proxima Centauri b is roughly 3 times the mass of Earth, suggesting that it could have a rocky composition. This is important because a rocky surface can potentially support liquid water and provide a stable environment for life. However, life on Proxima Centauri b would face some unique challenges. Red dwarf stars like Proxima Centauri are known for their stellar activity, including flares that could occasionally blast the planet with harmful radiation. Understanding the atmosphere of Proxima Centauri b is crucial in determining its habitability. If it has a strong magnetic field and a substantial atmosphere, it could shield the surface from these harsh conditions, creating a more stable environment for life to thrive. Additionally, its close proximity to Earth means that future missions could potentially send probes or even manned spacecraft to study the planet directly, a prospect that is far more feasible than for more distant exoplanets. Despite the challenges, the proximity of Proxima Centauri b and its location in the habitable zone make it one of the most promising candidates in our search for life beyond Earth. Imagine the possibility of observing a sunset on Proxima Centauri b, with its red dwarf star casting a soft, reddish glow over an alien landscape. As we continue to investigate this fascinating world, each new piece of data brings us closer to understanding whether life could exist so close to our cosmic doorstep. Next, we will journey to an even more distant part of the galaxy to examine the intriguing possibilities offered by TRAPPIST-1e, part of a unique system of potentially habitable planets. The TRAPPIST-1 system is truly one of the most remarkable discoveries in recent years, captivating scientists and space enthusiasts alike with its 7 Earth-sized planets. Located about 39 light-years away from Earth, this system orbits an ultra-cool dwarf star named TRAPPIST-1. What's fascinating is that 3 of these 7 planets, known as TRAPPIST-1d, TRAPPIST-1e, and TRAPPIST-1f, reside in the star's habitable zone, where conditions could be just right for liquid water to exist. Let's dive into the details of these intriguing worlds. First, let's explore TRAPPIST-1d. This planet is slightly smaller than Earth and orbits its star at a distance that allows for potential surface temperatures to support liquid water. The exact composition of its atmosphere remains a mystery, but its location within the habitable zone makes it a significant candidate for further study. The next planet, TRAPPIST-1e, is often considered the most Earth-like of the 3. It is nearly the same size and mass as Earth, suggesting a rocky composition. What makes TRAPPIST-1e particularly exciting is its position in the middle of the habitable zone, which increases the likelihood of stable, temperate conditions. Scientists believe that if TRAPPIST-1e has a thick enough atmosphere, it could maintain liquid water on its surface. Finally, TRAPPIST-1f is slightly farther out in the habitable zone. While it is also similar in size to Earth, it receives less energy from its star, meaning it could have colder surface temperatures. However, if TRAPPIST-1F possesses a greenhouse gas-rich atmosphere, it could still potentially support liquid water. The close proximity of these planets to each other within the TRAPPIST-1 system is another fascinating aspect. If you were standing on one of these worlds, you might see the other planets as large, moon-like objects in the sky, a sight that would be nothing short of spectacular. Each of these planets orbits TRAPPIST-1 in a matter of days, with TRAPPIST-1D completing an orbit in just 4 days and TRAPPIST-1F taking about 9 days. This means that a year on these planets is incredibly short compared to Earth. The TRAPPIST-1 system offers a unique opportunity to study multiple potentially habitable planets within a single system. Understanding the atmosphere's surface conditions and potential for life on these planets could provide invaluable insights into the diversity of planetary environments that exist in our galaxy. As we continue to study the TRAPPIST-1 system, we get closer to answering the tantalizing question of whether the conditions for life as we know it are common in the universe. Join us in our next segment as we journey even farther to explore the intriguing possibilities offered by Gliese 667cc, another fascinating candidate for habitability. The next planet we will spotlight is TRAPPIST-1e, celebrated for its Earth-like conditions. TRAPPIST-1e stands out in the TRAPPIST-1 system due to its striking similarities to our own planet. Nearly matching Earth in size and mass, TRAPPIST-1e is a rocky planet, a fundamental characteristic that enhances its potential for habitability. Its position in the middle of the habitable zone is particularly significant, as it suggests the planet could maintain a stable, temperate climate conducive to liquid water. Scientists are particularly intrigued by the possibility of TRAPPIST-1e having a thick atmosphere. A rich atmosphere can regulate surface temperatures, protect the planet from harmful space radiation, and support weather patterns that distribute heat more evenly across the globe, all of which are crucial for sustaining life. If TRAPPIST-1e has a dense, oxygen-rich atmosphere similar to Earth's, it could be a prime candidate for supporting liquid water, an essential ingredient for life as we know it. The potential for liquid water on TRAPPIST-1e's surface makes it one of the most exciting exoplanets studied so far. Water is critical because it acts as a solvent for biochemical reactions, providing a medium in which life's building blocks can interact. TRAPPIST-1e's location, along with its size and composition, suggest that it could have the right conditions for maintaining liquid water, which would be a groundbreaking discovery. Imagine walking on TRAPPIST-1e, feeling the cool breeze of its alien air, and perhaps even seeing water bodies that mirror those on Earth. The day-night cycle on TRAPPIST-1e, resulting from its orbital period, likely plays a crucial role in regulating its climate, possibly creating environments where life can flourish. Each advancement in the study of TRAPPIST-1e brings us closer to understanding whether this distant world could support life. Although we are still far from sending probes or manned missions to explore TRAPPIST-1e directly, every piece of data we collect from telescopes and simulations helps us piece together the puzzle of its habitability. The allure of TRAPPIST-1e lies in its potential to be a mirror image of Earth, a place where life could exist beyond our solar system. This tantalizing possibility fuels our quest for knowledge and drives us to keep exploring the cosmos. Stay tuned as we continue our journey to explore more potentially habitable planets. Next up is Gliese 667cc, another fascinating candidate in our search for extraterrestrial life. The next exoplanet on our list is TRAPPIST-1F, another intriguing candidate for habitability within the remarkable TRAPPIST-1 system. TRAPPIST-1F is similar in size to Earth, which suggests it may have a rocky surface. This is a promising sign, as rocky planets are more likely to have the essential conditions needed to support life. TRAPPIST-1F orbits in the outer part of the habitable zone of its parent star. This means it receives less energy compared to its neighbors, TRAPPIST-1D and TRAPPIST-1e. Consequently, its surface temperatures could be colder, potentially resulting in a different climate and environment. However, if TRAPPIST-1F has a thick atmosphere rich in greenhouse gases, it could trap enough heat to maintain liquid water on its surface. This greenhouse effect is crucial because it could create a temperate environment conducive to life, despite the planet's greater distance from its star. Scientists are eager to learn more about the atmospheric composition of TRAPPIST-1F. A substantial atmosphere could protect the planet's surface from harmful space radiation and help in maintaining a stable climate, vital for sustaining life. The study of TRAPPIST-1F's atmosphere is ongoing, with researchers using advanced telescopes to detect possible signs of water vapor, carbon dioxide, and other gases that are indicators of a habitable environment. The relatively short orbital period of TRAPPIST-1F, about 9 Earth days, means that its year is much shorter than ours. This rapid orbit could result in unique weather patterns and climate dynamics, which might impact the potential habitability of the planet. Imagine standing on TRAPPIST-1F, looking up at its ultra-cool dwarf star TRAPPIST-1, and seeing its neighboring planets as bright celestial objects in the sky. This close proximity offers a unique view of the TRAPPIST-1 system, unlike anything seen from Earth. The potential for life on TRAPPIST-1F, combined with its Earth-like size and intriguing position in the habitable zone, makes it a significant target for future research. As technology advances, we may one day send missions to explore these distant worlds directly, unraveling the secrets of their atmospheres and surface conditions. TRAPPIST-1F continues to captivate scientists and space enthusiasts alike, inspiring further studies into its habitability and the potential for life beyond our solar system. Join us as we continue our cosmic journey to uncover more about Gliese 667cc, a fascinating exoplanet with its own unique potential for supporting life. The fourth planet on our list is LHS 1140b, a fascinating super-Earth located around 40 light-years away in the constellation Cetus. Discovered in 2017, LHS 1140b orbits the red dwarf star LHS 1140 and has quickly gained attention due to its potential to support life. One of the most intriguing aspects of LHS 1140b is its size, with a diameter about 1.4 times that of Earth and a mass nearly 7 times greater. It falls into the category of super-Earth. This larger mass suggests a dense, rocky composition, which is critical for potentially sustaining life. The planet's orbit is another key factor contributing to its habitability prospects. LHS 1140b resides in the habitable zone of its parent star, where temperatures could allow for the presence of liquid water. It completes one orbit around LHS 1140 in about 24.7 days, placing it much closer to its star than Earth is to the Sun. However, because LHS 1140 is a red dwarf, it emits less energy than our Sun, allowing LHS 1140b to maintain temperatures that are conducive to liquid water despite its proximity. Scientists are particularly excited about LHS 1140b because its dense atmosphere, if present, could act as a shield against the star's radiation, helping to maintain a stable climate on the planet's surface. The potential thick atmosphere could also create conditions suitable for weather patterns and possibly even liquid water, both essential for life as we know it. Moreover, the planet's relative closeness to Earth makes it an excellent candidate for future observations and studies. Telescopes like the Hubble Space Telescope and the upcoming James Webb Space Telescope can analyze LHS 1140b's atmosphere in detail, searching for signs of water vapor, oxygen, and other gases that might indicate habitability. Imagine standing on LHS 1140b, looking up at the sky and seeing its red dwarf star glowing softly, casting a gentle light over the landscape. the potential for discovering life on such a planet is tantalizing and drives the ongoing research and exploration. Each new discovery about LHS 1140b brings us closer to understanding whether it could harbor life. As technology advances, the possibility of sending missions to study LHS 1140b directly becomes more feasible, offering an exciting glimpse into the potential habitability of planets beyond our solar system. Stay with us as we continue our journey to uncover more potentially habitable worlds. Next up, we will explore the intriguing possibilities offered by Teegarden b, another fascinating exoplanet in our quest to find life beyond Earth. The next planet on our list is Ross 128b, a compelling candidate in our search for habitable worlds. Discovered in 2017 by a team using the European Southern Observatory's HARPS spectrograph, Ross 128b orbits the red dwarf star Ross 128. Located just 11 light-years away from Earth in the constellation Virgo, Ross 128b has quickly become a focus of interest due to its promising characteristics. One of the most enticing features of Ross 128b is its position within the habitable zone of its star. This zone allows for temperatures that could support liquid water, which is essential for life as we know it. Ross 128b is approximately 1.35 times the mass of Earth, suggesting a rocky composition, which is crucial for maintaining surface water and providing a stable environment for life to potentially develop. What sets Ross 128b apart from many other red dwarf planets is the relatively low stellar activity of its parent star. Red dwarf stars are often known for their powerful flares that can blast nearby planets with harmful radiation. However, Ross 128 is a much quieter star, exhibiting significantly less stellar flare activity compared to others like Proxima Centauri. This low activity means that Ross 128b is less likely to be subjected to intense radiation, which can strip away a planet's atmosphere and make it inhospitable to life. The stable environment produced by Ross 128's calm demeanor increases the chances that Ross 128b could maintain a thick, protective atmosphere. This atmosphere would not only shield the planet from space radiation, but also help sustain a stable climate, potentially allowing for liquid water to exist on its surface. Imagine standing on Ross 128b, experiencing a gentle climate and looking up at its quiet, distant star glowing softly in the sky. The reduced likelihood of intense stellar flares means that any potential life on Ross 128b would face fewer threats from space weather, creating a more stable environment for biological development. The relatively close proximity of Ross 128b to Earth also makes it an excellent target for future observations and studies. Advanced telescopes can analyze its atmosphere to detect signs of water vapor, oxygen, and other gases that could indicate habitability. Each new piece of data brings us closer to understanding whether Ross 128b could be a suitable home for life beyond our solar system. As we continue to refine our techniques and technologies, the prospect of exploring Ross 128b in greater detail becomes ever more exciting. Stay tuned as we embark on the next segment of our cosmic journey, where we will delve into the intriguing possibilities offered by K218b, another fascinating exoplanet that holds promise in our quest to uncover extraterrestrial life. The fifth planet on our list is GJ667cc, an extraordinary exoplanet located in a multi-star system, situated approximately 23.6 light-years away in the constellation Scorpius. GJ667cc orbits one of the stars in the triple star system GJ667. This unique environment provides fascinating insights into the planet's habitability prospects. GJ667cc orbits the star GJ667c, which is a red dwarf. Despite being the smallest and least luminous of the three stars in the system, GJ667c plays a crucial role in the potential habitability of GJ667cc. The planet resides in the habitable zone of GJ667c, where conditions might allow for liquid water to exist. GJ667cc completes an orbit around its star in about 28 days, placing it relatively close to GJ667c. This close proximity is offset by the fact that GJ667c emits significantly less energy than our Sun, allowing for a stable climate that could support life. One of the intriguing aspects of GJ667cc is its size. It is approximately 4-5 times the mass of Earth, classifying it as a super-Earth. This larger mass suggests a rocky composition, which is essential for maintaining liquid water on the surface. The planet's position within the habitable zone, combined with its rocky nature, makes it a strong candidate for further study. Living on GJ667cc would offer a unique experience due to the multi-star system. Observers on the planet would see GJ667c as a bright red sun in the sky, while the other two stars, GJ667a and GJ667b, would appear as bright points of light possibly visible during the day. This multi-sun system could create spectacular skies and unique environmental conditions. Scientists are particularly interested in the atmospheric composition of GJ667cc. A thick atmosphere could help regulate the planet's climate, protect against harmful space radiation, and sustain liquid water. Current studies focus on detecting signs of water vapor, carbon dioxide, and other gases that are critical for habitability. The presence of multiple stars in the system might also impact the climate and weather patterns on GJ667cc. The gravitational interactions between the stars could influence the planet's orbit, potentially affecting its climate stability. Understanding these complex dynamics is key to assessing the planet's habitability. Despite being in a multi-star system, GJ667cc's proximity to its red dwarf star and its location in the habitable zone make it one of the most promising candidates for supporting life. As research continues, we may uncover more about its atmosphere, surface conditions, and potential for hosting life. Imagine standing on GJ667cc, witnessing a sunset with multiple stars painting the sky in hues of red and orange. The unique environment and potential habitability make GJ667cc a captivating subject for study. As we move forward in our journey, we will next explore the intriguing world of K2-18b, another exoplanet that holds promise in the search for life beyond Earth. The sixth planet on our list is K2-18b, an exoplanet that has garnered significant attention due to the discovery of water vapor in its atmosphere. Located about 124 light-years away in the constellation Leo, K2-18b orbits a red dwarf star named K2-18. This intriguing find was announced in 2019 by two independent research teams using data from the Hubble Space Telescope. The presence of water vapor is a crucial indicator when assessing the habitability potential of an exoplanet. Water is essential for life as we know it, facilitating numerous biochemical reactions necessary for living organisms. The discovery of water vapor in K2-18b's atmosphere raises exciting possibilities about its ability to support life. K2-18b is classified as a super-Earth with a mass about 8.6 times that of Earth and a radius approximately 2.7 times larger. This size suggests that it could have a thick atmosphere, which in turn can help maintain stable surface temperatures and protect against harmful space radiation. The planet resides in the habitable zone of its parent star, where conditions could allow for liquid water. One of the fascinating aspects of K2-18b is the composition of its atmosphere. Alongside water vapor, scientists have detected hydrogen and helium, hinting at a complex atmospheric structure. If K2-18b has a substantial amount of water vapor, it could imply the presence of clouds and weather systems similar to those on Earth. The implications for habitability are significant. A thick, water-rich atmosphere can regulate the planet's climate, providing a stable environment where life could potentially arise. This atmosphere also acts as a shield, protecting the surface from the star's radiation. For future explorations, K2-18b presents an exciting target. Advanced telescopes such as the James Webb Space Telescope will be able to examine its atmosphere in greater detail, searching for further signs of habitability, like the presence of other gases associated with biological activity. Imagine standing on K2-18b, sensing a humid air filled with water vapor, possibly seeing clouds forming in an alien sky. The discovery of water vapor brings us closer to understanding whether this distant world could support life. Every new finding about K2-18b provides valuable insights into its environment and potential for habitability. As we continue our quest to uncover more about these fascinating exoplanets, stay with us as we journey next to explore the possibilities offered by Teegarden b, another exciting candidate in our search for extraterrestrial life. Teegarden star b, close yet hidden characteristics of this nearby exoplanet and its potential for life. The seventh planet on our list is Teegarden star b, located just 5 light-years away in the constellation Aries. Discovered in 2019 by a team of astronomers using the Kármán instrument, Teegarden star b orbits a red dwarf star named Teegarden star. This nearby exoplanet stands out due to its proximity and intriguing potential for habitability. One of the key characteristics of Teegarden star b is its size, which is similar to Earth's, with an estimated mass of about 1.05 times that of Earth. Teegarden star b falls into the category of Earth-like planets. This similarity in size suggests that the planet could have a rocky composition, an essential factor for supporting life. Another significant feature of Teegarden star b is its position within the habitable zone of its parent star. Teegarden star is a very old red dwarf, approximately 8 billion years old, and emits much less energy than our Sun. This allows Teegarden star b to orbit very close to its star while maintaining temperatures that could allow for the presence of liquid water. The planet completes an orbit around Teegarden star in just about 9 days, making its year much shorter than an Earth year. This rapid orbit places Teegarden star b well within the habitable zone, where conditions might be right for liquid water to exist on the surface. Despite its closeness to the star, the lower energy output of Teegarden star creates a stable environment in which life could potentially develop. Scientists are particularly interested in the atmosphere of Teegarden star b. If it has a dense atmosphere, it could protect the planet's surface from space radiation and help maintain a stable climate. The presence of a thick atmosphere would also increase the chances of surface water, a crucial ingredient for life. The age of Teegarden star adds another layer of intrigue. Being roughly twice as old as our Sun, the extended period of stability could have provided ample time for any potential life forms to evolve on Teegarden star b. This long duration increases the likelihood that the planet's conditions have remained conducive to life. Imagine standing on Teegarden star b, experiencing a gentle, reddish light from its parent star and contemplating the ancient skies of this nearby world. The potential for habitability on Teegarden star b, combined with its proximity to Earth, makes it a prime candidate for future research. As advancements in technology continue, we may soon be able to study this intriguing exoplanet in greater detail, searching for signs of life and understanding its environment. Stay with us as our journey continues to explore other potentially habitable worlds. Next up is Tau Ceti e, an exoplanet that holds promise in our ongoing quest to find extraterrestrial life. The eighth planet on our list is Wolf 1061c, which resides in the habitable zone of its parent star, Wolf 1061. Located approximately 14 light-years away in the constellation Ophiuchus, Wolf 1061c has garnered significant interest due to its potential to support life. One of the most intriguing aspects of Wolf 1061c is its position within the habitable zone, often referred to as the Goldilocks zone. This region around a star is where conditions are just right for liquid water to exist. Wolf 1061c's placement in this zone suggests that it could have temperatures that allow for the presence of liquid water on its surface, an essential ingredient for life as we know it. Wolf 1061, the host star, is a red dwarf which emits less energy than our Sun. This lower energy output allows planets like Wolf 1061c to orbit closer to the star while still maintaining potentially habitable conditions. Wolf 1061c completes an orbit around its star in about 18 Earth days, placing it well within the habitable zone where temperatures could support liquid water. Wolf 1061c is classified as a super-Earth with a mass about 3 times that of Earth. This larger size suggests a rocky composition, which is crucial for supporting surface water and providing a stable environment for potential life forms. The planet's rocky nature, combined with its advantageous position in the habitable zone, makes it a prime candidate for further study. The atmosphere of Wolf 1061c is a subject of great interest among scientists. A thick atmosphere could help maintain a stable climate, protect the planet from space radiation, and potentially support weather patterns that distribute heat evenly. The presence of an atmosphere rich in gases like carbon dioxide and water vapor could create greenhouse effects that are vital for maintaining liquid water. Imagine standing on Wolf 1061c, feeling the warmth of its red dwarf star and pondering the possibilities of life on this distant world. Wolf 1061c's proximity to Earth makes it an excellent target for future exploration. As technology progresses, missions could be designed to send probes or even manned spacecraft to study the planet directly, offering unparalleled insights into its habitability. With each new discovery, we draw closer to understanding whether Wolf 1061c could support life, further fueling our quest to find extraterrestrial civilizations. Stay with us as we continue our exploration of potentially habitable planets. Next up is Tau Ceti e, another fascinating candidate in our search for life beyond Earth. The 9th planet on our list is Gliese 832c, a potential super-Earth that has captured the interest of scientists due to its size, orbit, and potential for supporting liquid water. Located about 16 light-years away in the constellation Grus, Gliese 832c orbits its parent star, Gliese 832, a red dwarf star known for its relatively low energy output. This makes the conditions on Gliese 832c particularly intriguing when it comes to the possibility of habitability. Gliese 832c is classified as a super-Earth with a mass approximately 4 times that of Earth. This significant size suggests a rocky composition, which is critical for potentially sustaining liquid water on its surface. The planet's orbit is another key factor that makes it a candidate for habitability. Gliese 832c resides in the habitable zone of its parent star, where temperatures could allow for the presence of liquid water. It completes an orbit around Gliese 832 in about 36 days, placing it much closer to its star compared to Earth's distance from the Sun. However, due to Gliese 832 low energy output, this close proximity results in surface temperatures that could be suitable for liquid water. Scientists are particularly excited about the possibility of Gliese 832c having a thick atmosphere. A dense atmosphere could help regulate the planet's climate, protecting the surface from harmful space radiation and maintaining conditions that are conducive to liquid water. The greenhouse effect created by such an atmosphere could play a vital role in ensuring that surface temperatures remain stable and warm enough to support life. Imagine standing on Gliese 832c, feeling the gentle warmth from its red dwarf star and perhaps seeing liquid water bodies spread across the landscape. The potential for water on Gliese 832c makes it one of the most enticing candidates for further study in the quest to find life beyond Earth. As telescopes and observational technologies advance, scientists are eager to analyze Gliese 832c's atmosphere in greater detail, searching for signs of water vapor, carbon dioxide, and other gases that could indicate habitability. The allure of discovering a super-Earth with conditions suitable for life drives ongoing research and exploration efforts. Every piece of data collected brings us a step closer to understanding whether Gliese 832c could support life as we know it. Our journey through the cosmos continues to reveal fascinating possibilities, and Gliese 832c stands out as a beacon of hope in our search for extraterrestrial environments. Stay tuned as we explore the next potentially habitable world on our list, Lytton B, another fascinating exoplanet that fuels our quest to uncover the mysteries of life beyond Earth. The 10th planet on our list is HD 40307G, a fascinating super-Earth located about 42 light-years away in the constellation Pictor. Discovered in 2012, HD 40307G orbits its parent star, HD 40307, which is a K-type main sequence star. What sets HD 40307G apart is its long orbital period, which plays a significant role in its potential habitability. The planet completes one orbit around its star in approximately 197 Earth days, placing it within the habitable zone, where conditions might be suitable for liquid water to exist on its surface. This extended orbit means HD 40307G experiences more gradual seasonal changes, which could create a stable climate conducive to life. The length of this orbit allows for a balanced distribution of heat, reducing the likelihood of extreme temperature fluctuations that could make the environment hostile for life. HD 40307G is classified as a super-Earth with a mass about 7.1 times that of Earth, suggesting a rocky composition with a possibly thick atmosphere. This dense atmosphere could regulate surface temperatures, protect against space radiation, and support complex weather patterns, all essential for sustaining life. The parent star, HD 40307, being a K-type star, emits less energy than our Sun. This lower energy output allows HD 40307G to orbit farther away while still maintaining temperatures that could support liquid water. The combination of the star's characteristics and the planet's long orbital period provides a promising environment for habitability. Imagine standing on HD 40307G, experiencing a year nearly twice as long as an Earth year, with its extended seasons creating a unique and stable climate. The potential for liquid water, combined with the stability provided by the long orbit, makes HD 40307G an intriguing candidate for further study in the search for extraterrestrial life. As telescopes and other observational tools advance, scientists are eager to analyze HD 40307G's atmosphere for signs of water vapor, oxygen, and other gases that might indicate habitability. Each new discovery brings us closer to understanding whether HD 40307G could harbor life. Stay with us as we continue to explore more potentially habitable planets. Next up is Kepler 442b, another fascinating candidate in our quest to uncover the mysteries of life beyond Earth. The 11th planet on our list is Captain B, an ancient world that has intrigued scientists with its age, characteristics, and potential for hosting life. Captain B orbits the red subdwarf star Captain, located approximately 13 light-years away in the constellation Pictor. What sets Captain B apart is its remarkable age, estimated to be around 11.5 billion years old. This makes it more than twice as old as Earth and the Sun, offering a unique glimpse into the early history of our galaxy. Captain B's ancient origins suggest that it formed in a much earlier and potentially more chaotic period of the Milky Way's history. Its long existence raises fascinating questions about the possible evolution of life over such an extensive timescale. The planet's age also implies that it may have witnessed numerous cosmic events, including supernova and the formation of our solar system. One of Captain B's key characteristics is its position within the habitable zone of its parent star. The planet completes one orbit around Captain in just about 48 days, placing it at a distance where temperatures could allow for the presence of liquid water. This proximity to the star, combined with the low energy output of a red subdwarf, creates conditions that could be conducive to life. Captain B is classified as a super-Earth with a mass approximately 4.8 times that of Earth. This substantial mass suggests a rocky composition, which is crucial for the potential development of life. The planet's size and location make it a prime candidate for further investigation into its atmospheric conditions and surface environment. Scientists are particularly interested in the potential atmosphere of Captain B. If it has retained a dense atmosphere over its long history, it could protect the surface from space radiation and maintain a stable climate. The presence of water vapor, carbon dioxide, or other greenhouse gases could create a warming effect that allows liquid water to exist, despite the planet's distance from its star. Imagine standing on Captain B, observing the ancient skies of a world that has existed for billions of years. The potential for life on such an old planet is tantalizing, as it could provide insights into how life might arise and evolve under different cosmic conditions. The long duration of stability offered by Captain B's age enhances the chances that life could have developed and persisted over time. The study of Captain B is ongoing, with scientists using advanced telescopes to analyze its atmospheric composition and search for signs of habitability. Each new discovery about this ancient world brings us closer to understanding the potential for life beyond our solar system and the history of life in the universe. Stay tuned as we continue our journey to explore more potentially habitable planets. Next on our list is Kepler 442b, another intriguing candidate in our quest to uncover the mysteries of life beyond Earth. The 12th planet on our list is Tau Ceti e, an intriguing exoplanet located in the Tau Ceti system, which is about 11.9 light-years away from Earth in the constellation Cetus. Tau Ceti e is one of 5 known planets orbiting the star Tau Ceti, but it stands out among its siblings for several compelling reasons. Tau Ceti e resides in what is known as the inner edge of the habitable zone of its parent star. This zone is where temperatures could allow for liquid water to exist, making it a significant candidate for habitability. The planet completes an orbit around Tau Ceti in about 163 days, suggesting that it experiences shorter, potentially milder seasons compared to Earth. Tau Ceti is a G-type main sequence star, similar to our Sun but slightly less luminous. This means that the planets orbiting Tau Ceti, including Tau Ceti e, receive less energy, which is a critical factor in maintaining a stable environment for life. Tau Ceti e is classified as a super-Earth with a mass about 4.3 times that of Earth, suggesting a rocky composition. This rocky nature is crucial for supporting surface water and providing the stability needed for life forms to develop. One of the fascinating aspects of Tau Ceti e is its potential atmosphere. If it has a thick atmosphere rich in greenhouse gases like carbon dioxide, it could regulate temperatures and create conditions suitable for liquid water. This atmosphere would also protect the planet from harmful space radiation, further enhancing its habitability prospects. Tau Ceti's position among its sibling planets is particularly noteworthy. While several of these planets fall within or near the habitable zone, Tau Ceti's placement at the inner edge makes it a strong candidate for having the right conditions to support life. The stability of the Tau Ceti system, with its lack of excessive stellar activity, also contributes to a favorable environment for habitability. Imagine standing on Tau Ceti, experiencing its unique climate and looking up at the sky to see the familiar light of a star not unlike our Sun. The potential for life on this super-Earth is tantalizing, as it offers a glimpse into the possibilities of rocky worlds in the habitable zones of other stars. Each new discovery about Tau Ceti and its atmosphere brings us closer to understanding whether it could support life. The study of Tau Ceti continues, with scientists using advanced telescopes to analyze its atmospheric composition and search for signs of habitability. As we gather more data, we may uncover more about its potential to host life and what it can teach us about the conditions necessary for life to thrive in the universe. Stay with us as we continue our journey to explore more potentially habitable planets. Next on our list is Kepler 442b, another fascinating candidate that holds promise in our search for extraterrestrial life. The 13th planet on our list is Kepler 186f, notable for being the first Earth-sized planet discovered within the habitable zone of its star. This milestone finding was announced by NASA in 2014, sparking significant interest and further research into its potential for habitability. Kepler 186f orbits the star Kepler 186, which is a red dwarf located approximately 500 light-years away in the constellation Cygnus. What sets Kepler 186f apart is its size and position in the habitable zone, which make it an exciting candidate for supporting life. Kepler 186f is remarkably similar to Earth in size, with a radius about 1 times that of our planet. This similarity suggests that it is likely rocky, a crucial factor for habitability since rocky planets can potentially support liquid water on their surfaces. Its placement in the habitable zone of its parent star means that temperatures could be just right for liquid water to exist, an essential condition for life as we know it. The orbit of Kepler 186f around its red dwarf star is another intriguing aspect. The planet completes one orbit in approximately 130 Earth days, placing it within the habitable zone where conditions might allow for a stable climate conducive to life. Red dwarfs emit less energy than our Sun, which means Kepler 186f can maintain stable, habitable temperatures while orbiting closer to its star. One of the key areas of interest for scientists is the atmosphere of Kepler 186f. If this exoplanet has a substantial atmosphere, it could help regulate surface temperatures, protect against harmful space radiation, and sustain weather patterns that distribute heat evenly. An atmosphere rich in gases like carbon dioxide and water vapor could create the greenhouse effect necessary for maintaining liquid water. Imagine standing on Kepler 186f, looking up at its red dwarf star and seeing a sky that blends the familiar with the alien. The potential for water and a stable climate makes Kepler 186f one of the most promising candidates for habitability discovered so far. This discovery has significant implications for our understanding of where life might exist beyond Earth. The excitement surrounding Kepler 186f has spurred additional research and observation, with advanced telescopes aiming to decipher more details about its atmosphere and surface conditions. Each piece of data brings us closer to determining the true habitability potential of this Earth-sized world. As we continue our quest to find life beyond our solar system, the discovery of Kepler 186f marks a groundbreaking step in the search for Earth-like planets. Stay tuned as we explore the next planet on our list, Kepler 62f, another fascinating exoplanet with its own unique potential for supporting life. The 13th planet on our list is Kepler 186f, notable for being the first Earth-sized planet discovered within the habitable zone of its star. This milestone finding was announced by NASA in 2014, sparking significant interest and further research into its potential for habitability. Kepler 186f orbits the star Kepler 186, which is a red dwarf located approximately 500 light-years away in the constellation Cygnus. What sets Kepler 186f apart is its size and position in the habitable zone, which make it an exciting candidate for supporting life. Kepler 186f is remarkably similar to Earth in size, with a radius about 1 times that of our planet. This similarity suggests that it is likely rocky, a crucial factor for habitability since rocky planets can potentially support liquid water on their surfaces. Its placement in the habitable zone of its parent star means that temperatures could be just right for liquid water to exist, an essential condition for life as we know it. The orbit of Kepler 186f around its red dwarf star is another intriguing aspect. The planet completes one orbit in approximately 130 Earth days, placing it within the habitable zone where conditions might allow for a stable climate conducive to life. Red dwarfs emit less energy than our Sun, which means Kepler 186f can maintain stable, habitable temperatures while orbiting closer to its star. One of the key areas of interest for scientists is the atmosphere of Kepler 186f. If this exoplanet has a substantial atmosphere, it could help regulate surface temperatures, protect against harmful space radiation, and sustain weather patterns that distribute heat evenly. An atmosphere rich in gases like carbon dioxide and water vapor could create the greenhouse effect necessary for maintaining liquid water. Imagine standing on Kepler 186f, looking up at its red dwarf star and seeing a sky that blends the familiar with the alien. The potential for water and a stable climate makes Kepler 186f one of the most promising candidates for habitability discovered so far. This discovery has significant implications for our understanding of where life might exist beyond Earth. The excitement surrounding Kepler 186f has spurred additional research and observation, with advanced telescopes aiming to decipher more details about its atmosphere and surface conditions. Each piece of data brings us closer to determining the true habitability potential of this Earth-sized world. As we continue our quest to find life beyond our solar system, the discovery of Kepler 186f marks a groundbreaking step in the search for Earth-like planets. Stay tuned as we explore the next planet on our list, Kepler 62f, another fascinating exoplanet with its own unique potential for supporting life. What lies ahead are future missions and discoveries. Upcoming missions and technologies promise to revolutionize our search for habitable planets and deepen our understanding of these distant worlds. One of the most anticipated missions is the James Webb Space Telescope, set to launch soon. This telescope will offer unprecedented capabilities, allowing scientists to examine the atmospheres of exoplanets with greater precision than ever before. By analyzing the light passing through these atmospheres, the James Webb Space Telescope will help identify the presence of key gases like oxygen, methane, and water vapor, which are essential for life. Another exciting development is the European Space Agency's Pluto mission. Scheduled for launch in the near future, Pluto aims to find and characterize Earth-sized exoplanets orbiting Sun-like stars. This mission will not only increase the number of potentially habitable planets we know about, but also provide detailed information about their orbits, sizes, and compositions. The Transiting Exoplanet Survey Satellite, or TESS, continues to expand our catalog of exoplanets. Since its launch, TESS has already discovered thousands of new exoplanet candidates. Future data from TESS will be crucial in identifying more habitable worlds and directing follow-up studies by more powerful telescopes. Ground-based observatories are also playing a significant role in this quest. The extremely large telescope currently under construction in Chile will have a mirror 39 meters in diameter, making it the largest optical and infrared telescope in the world. Its incredible resolution will allow astronomers to study the atmospheres of exoplanets in detail, searching for biosignatures that indicate the presence of life. In addition to these missions, the development of new technologies like starshades and coronagraphs will enhance our ability to directly image exoplanets. These technologies work by blocking out the light from a star, allowing us to see the faint light reflected by the planets orbiting it. Direct imaging will enable us to observe planetary surfaces and climates, providing a more comprehensive understanding of their habitability. As we look to the future, collaborations between space agencies, universities, and private organizations will be essential in advancing our search for habitable planets. The combination of innovative missions and cutting-edge technologies holds the promise of making groundbreaking discoveries. Imagine the day when we find definitive evidence of life on another planet, changing our understanding of the universe forever. The journey ahead is filled with excitement and possibilities as we continue to explore the cosmos, driven by our innate curiosity and desire to understand our place in the vast expanse of space. Join us in our next segment as we delve deeper into these future missions and the incredible technologies that will pave the way for discovering new worlds. Stay curious and keep looking up. The implications of finding life on a habitable planet are profound and far-reaching, potentially transforming our understanding of life and the universe in several fundamental ways. First and foremost, discovering extraterrestrial life would answer one of humanity's most enduring questions. Are we alone in the universe? This revelation would have a profound impact on our view of our place in the cosmos. It would suggest that life is not a unique phenomenon to Earth, but rather a common occurrence throughout the universe. Such a discovery would prompt a re-evaluation of the processes that lead to the emergence of life, possibly revealing new biological principles and environmental conditions that foster life. Beyond the scientific implications, the discovery of life on another planet could have significant philosophical and existential ramifications. It would challenge long-held beliefs and assumptions about the uniqueness of human existence, prompting deep reflection on our role in the universe and our responsibilities as stewards of life on Earth. This newfound perspective could foster a greater sense of unity and humility as we come to realize that we are part of a much larger cosmic community. The search for habitable planets and potential extraterrestrial life also drives advancements in technology and international collaboration. The development of cutting-edge telescopes, spacecraft, and observational techniques not only enhances our ability to explore distant worlds but also has practical applications that benefit life on Earth. The quest to find habitable planets fosters a spirit of cooperation among scientists, space agencies, and nations as they work together to unravel the mysteries of the universe. Economically, the discovery of life beyond Earth could have significant implications as well. It could spur investment in space exploration and related industries, driving innovation and creating new economic opportunities. Moreover, the potential for future human habitation on other planets could open up new frontiers for human expansion, with profound implications for the future of civilization. The discovery of life on another planet would also likely influence cultural and artistic expressions, inspiring new forms of storytelling, art, and music that reflect our expanded understanding of the universe and our place within it. The impact on education would be immense, as new generations of students are inspired to pursue careers in science, technology, engineering, and mathematics, driven by the excitement of exploring the unknown. In summary, finding life on a habitable planet would not only revolutionize our scientific understanding, but also reshape our philosophical, cultural, and economic landscapes. It would mark a new era in human history, one where we embrace our place in a vast and potentially inhabited universe. This discovery would propel humanity towards a future filled with exploration, discovery, and a deeper appreciation for the diversity of life. As we continue our search for habitable worlds, let us remain curious and open to the possibilities that lie beyond our own planet, ever driven by the quest to understand the cosmos and our place within it. Stay tuned as we delve deeper into these fascinating topics in our next segment. In summary, we have journeyed through 15 remarkable planets that scientists believe could be habitable. Starting with Kepler 452b, known as Earth 2.0, due to its striking similarities to our home planet, we then explored Proxima Centauri b, our closest neighbor in the search for life. The TRAPPIST-1 system offered multiple intriguing candidates, including TRAPPIST-1d, TRAPPIST-1e, and TRAPPIST-1f, each residing in the habitable zone of their ultra-cool dwarf star. LHS 1140b's dense, rocky composition and stable climate make it a prime target for future study. Ross 128b stands out for its relatively low stellar activity, which enhances its habitability prospects. GJ 667cc provides a unique environment within a multi-star system, while K2-18b's discovery of water vapor in its atmosphere has captured significant attention. Teegarden Star B, close and Earth-like in size, presents exciting possibilities for habitability. Wolf 1061c resides in the Goldilocks zone of its star, and Gliese 832c's potential thick atmosphere makes it an enticing candidate. HD 40307G's extended orbit creates a stable climate suitable for life, while Captain B's ancient origins offer a glimpse into the early history of our galaxy. Tau Ceti E, residing at the inner edge of its habitable zone, hints at a stable environment for life, and Kepler 186f's Earth-like size and position in its star's habitable zone make it a groundbreaking discovery. Finally, Kepler 62f's unique potential for supporting life adds to our growing list of intriguing exoplanets. As we look to the future, the pursuit of habitable planets promises to deepen our understanding of the universe and our place within it. The advancements in missions and technologies such as the James Webb Space Telescope, the Pluto mission, and the Transiting Exoplanet Survey satellite are set to revolutionize our search for extraterrestrial life. Ground-based observatories like the Extremely Large Telescope will provide unprecedented insights into planetary atmospheres and potential biosignatures. Discovering life on another planet would not only revolutionize science but also reshape our philosophical, cultural, and economic landscapes. It would mark a new era in human history, filled with exploration, discovery, and a deeper appreciation for the diversity of life. Let us remain curious and open to the possibilities that lie beyond our own planet, ever driven by the quest to understand the cosmos and our place within it. Thank you for joining us on this incredible journey through the universe. Don't forget to like, subscribe, and hit the notification bell to stay updated with our latest videos on space exploration. Until next time, keep looking up and stay curious.